Okay, in this quick video, what I'm going to do is just quickly go through what we did in the final day of the GIS practicals. Now really, this is about actually making something from a few bits of data. If we just have a look at the data that we've got, if you go to the exercise 1 directory, which is available on the U drive, into the data, you see that there's two main folders here. Maxent EVs, and the EVs mean environmental variables, and then Maxent sightings. Sightings are just point files, CSV files, which contain three different columns. First one, species, longitude, and latitude. Maxent, which is the modeling program we're going to use, we're only reading files which have this header and this order. So it needs to be species followed by longitude and non-latitude. Anything else means that this particular book will not work. Okay? What do you want, Dave? What do you want? So in essence, before I get interrupted, the species file just looks like this. 3 columns with some spatial reference in it there. Same again for all the others. The only difference is that we've just called the species name a different one. Okay? So to get these particular data into our GIS, it's very simple. All we're going to do is just add in this particular data set. I mean, my GIS looks slightly different to yours because I'm using the newest version of ARC, whereas you're using the previous one. But I'm going to use, everything that I do is essentially the same as what you do. So you click add, and it adds it in here, and you can see it's just a table. So we're just going to right click on it and go display it for our data. It automatically fills in the X and Y fields, which are correct, and it says unknown coordinate system. We're just going to define a coordinate system, which is a geographic one. We know that these data are in WGS 1984. Click add. Okay, just ignore that, that's nothing really important. And there we go, we can see our species information on our map here. Alright, so this is one of the first layers. What I'm just going to do is just add these in, the rest of them, into the dataset in preparation for the new one, the new model data that we're going to put in. Okay, so there we got our 4 different species in our dataset. Turn them off and on again, however you wish to do. Okay, so now what we're going to do is start generating our model. Now, Maxent is basically modeling distribution of a species based on some environmental layers, okay? So if we go into the directory Maxent EV, you can see that we've got several different environmental layers in here. 5 in total: aspect, chlorophyll, depth, slope, and sea surface temperature. Okay, and I've made these variables for you. All we're going to do is just load in the directory of this one here, which is man. We want that directory name, and we're going to put it straight into here. Okay, and you see it loads in the files automatically, and it gives you an option whether it's continuous or categorical. Now, categorical is, for example, a sediment type map, rock, sand, mud, silt, etc. Whereas continuous is a continuous variable across an axis, so temperature, depth, chlorophyll. Okay? Samples, we're just going to load in one of the species locations, and you see that it loads it in here with B physalis. So this is a particular model, this particular species that we're going to model based on these environmental data. Okay? So a couple of things that we need to do. You can check create response curves, which will give you a bit more information about your model and your species distribution. We can also select do jackknife to measure variable importance, which will tell you which variables were the most important ones within your model. But I'm going to leave these unchecked, but I want to make pictures of predictions. Keep that checked, because that will draw a quick picture so that you can just have a look to see if it's come out okay. Output directory is where you want this particular model to be dumped, okay? So I'm just going to make a new folder. I'm going to call it B physalis I'm just opening it there, okay? And that's where all the files from the output are going to be dumped, including new map of the predicted V5 style distribution, an HTML file which contains all of the model output, including how strong it is, etc., etc., etc. So we need to select a new clean directory file. Now, you can leave projection layers or directory file blank, but it's good practice to make sure that you actually use the correct location where your environmental layers are. Essentially, what Maxent does is it extracts a niche from locations in the environmental layers where points intersect it, and then it extrapolates that into areas which are unoccupied by a species and tries to predict the suitability of a habitat. So in projection layers, you can put in there, for example, you could put forecasted temperature change or forecasted use change in 100 years' time to see how that niche from present day species would change and the area will reduce. So it's just a way of seeing how some species may be affected by climate change. But it is good practice to insert the same location if you're working to predict the present day distribution and to generate a map for the present day distribution. Now, one final thing we have to do is just click settings. We need to change random test percentage to 30. Okay? So we're going to use 70% of our input points to generate the model. We're going to use 30% of the points to validate it. Those 30% will not be used in the creation of the model, so they are semi-independent, if you would. Okay? What we're going to do now is just click that X, and that will save the settings into the data set. So now, that's it. What we're going to do is click Run. And you see that it will just go very quickly through a variety of different things, calculating the gain, etc. It's actually developing the model now and trying to fit the model to the species distribution. It will be done in a few moments. Okay, so that's a very quick one. If we select these two options, it would take quite as long to run. So, going back into here now, we're going to find the location as specified where the output will be. So if we click it, you'll see it's now full of files. The most important ones for you are this one, the HTML document, and the ASC file, which is the modeled output. Just double click this and load up this HTML document. And you see a very nicely formatted output for your model. If we scroll down and see that there go, these numbers. Here is the prediction which has been generated. The right points are species locations which were used in the generation of the model. The purple points are validation points that were used to calculate the test AUC value. Variable contributions down here gives you an indication of the importance of each variable, and you can see that slope is the most important, followed by aspect, then depth. Down here, you see that we have a variety of different stats and points that were going on. So it's used 19 present points for training, 7 for validating. The validation has given us a test AUC of 0.93, which is very, very good. 0.93 indicates that we have produced an exceptional model. And that's a number that we need to use and report when we come through later. So now what I'm going to do is I'm going to import this file into our GIS so that we can see it. And to do that, I'm going to use Arc Toolbox. At the moment, it's an ASCII file. And if we're just to add that in to our GIS, it's not going to show properly because it's an ASCII file ranging from 0 to 1. By default, ArcGIS will just try and show it as a float value. So I'm just going to drag it in. And you see that it's just grey and it gives us some erroneous value here. Okay? So what I'm going to do is I'm going to convert that file to a raster. So we're using Arc Toolbox conversion tool to raster, and we're going to use ASCII to raster. So ASC is an ASCII. Just double click that tool. And you see, it's just very simply a few fields. We're going to find the file that we want to convert, which will be in your output directory. And the first one here, B5000, open. And then we're going to define the location for it to save. So we're just going to save that file to our original directory. And it's now going to be a raster, not an ASCII file. So I'm just going to call it B5. Remember, no extension, can't be more than 13 characters long, contain no spaces or first dot or anything. Now the most important thing to do is to change this from integer to float, otherwise it won't display properly. Just click OK. It should only take a few seconds. And the way that my GIS did it doesn't show a prompt, it just shows this thing down here. But as you can see, it's now done. I'm just going to zoom out, and you can see that the prediction is now in. Now the prediction here is shown as a stretched raster. What we're going to do is classify it by using the symbology tools which are part of the raster properties. We're just going to right click on B5000 and go to Properties, Symbology, and you can see we've got some different options here. We're just going to click Classify. It will ask you if you want to compute a histogram, click yes, and it will very quickly show you a classification scheme for that particular raster. Now, classification, we want to use defined interval of 0.2. Click OK. Because we've now got 5 categories. I'm going to select my favourite colour scheme, which is red to blue. But as you can see, red is at not at 1, which is what I want. So I'm just going to right click on this ramp, click flip colours, and you can see that I've now got this colour scheme going. And there we go. A much more conservative representation of the data. We just get our original points, overlay it on. We've now got the beginnings of a very good map, which shows where this particular species is. So what we're going to do now is add in some extra information. If you just let me find my some data that we can use for the country. This probably isn't the best one to use, but it's probably the lesser of two evils. We're going to try and use a reasonably high resolution map so that you can get quite a nice showing. I'm just going to make this black, which is again my favourite way of displaying this kind of information. Ignore the draw now. And zoom in. Okay, so that's our first species. Obviously you can do this again and again and again for different ones. Now what I'm going to do is just switch to layout view. I'm going to start organising how I display my map now. I'm going to create 4 different maps, one for each of those species. So I need to be able to fit them side by side. I'm going to try and make it as beautiful as I possibly can. Now, you see that it can be quite difficult to try and fit on the map and fit it to the aspect ratio. So what I've done is I've just moved the box to try and fit it quite well. I'm just going to zoom into the area of interest, the region of interest, and try and maximise that to fit the full box. And as you can see, I've managed to do that. It's fitting quite well. I'm just going to right click properties. I'm now going to add my gratitude to it as we've done before. Okay. 2 labels only. Font size, make it much larger. 214, we see what that's like. Pick a 5. Okay, that looks good. Probably that the label is a little bit too big. I'm just going to make that 12 instead. I'm going to turn the bottom right. And I'm also going to do adjusting the property to remove the zeros from the label. I don't want them. It contains no information. Okay, so we've now got a fairly decent looking map there. Downside is that these points aren't very clear. So I'm just going to change this to white, maybe a little bit smaller. Okay, so I'm pretty pleased with that map. It looks pretty good. I'm very happy with it. So what I'm going to do is, theoretically, I would run the model several times, once for each one of these species. Okay, so for example, Merlus. I would then import that in by doing the active-to-active conversion, and then I would add it in here and get the exact formatting exactly identical the best I can. I'm just going to do 1 or 2 just to show you my workflow. So exactly what we did before. Never forget to change this to float. Click OK. Now, I've got this one in here. What I'm going to do is very quickly duplicate this classification onto this one. So right click on Merlus, Properties, click Stretch, Classified Next Stretch, and you click Import. You can select the previous one and it will automatically import the exact same colour scale. I'm just going to drag this up here. I'm going to do exactly the same for this one. Properties, Symbology. I'm just going to click Import. I'm going to select B Physalis Event. Gives me exactly the same. Same size, exactly the same colour. Saves you lots and lots of time. So, turn that one off. I've now got 2 maps ready to go. What I'm going to do is copy this data frame. So I've now got 2 data frames, both containing the same data. I'm going to line them up to get it nice and perfect. And you see that I need to change my latitude onto the right, not the left hand side. So I'm just going to go into Properties to change that from left to right. And there we go. So we've now got 2 maps which look pretty good. Minimize the first one. And the second one, I'm just going to turn off B Physalis to make sure that Merlus is done. I've now got 2 identically orientated maps with different data. So it's very simple now to add in some labels that will allow me to identify each one. I'm just going to use the Draw toolbar, New Text Box, and I'm just going to B dot space. Oops, no. I'm just going to change the symbol, italics, Arial, white, bold, maybe make it 13. Click OK. I guess it's very obvious against the background. Copy and paste that. Okay, so I would repeat this for the other 2 by selecting these, copy, paste, and then I would move it down. Okay, and then obviously I've got to change the label location yet again. Properties grid, bottom. Okay, and there you go. A pretty professionally looking map which contains oodles of data. Obviously this one will be a different species and that one will be a different species, providing that you've done it in the right way. So I'm just going to move that down a bit, copy another data frame, paste it, put it up here, make an overview map. Turn off the species information. Let me zoom out. Zoom into European area. And then remember, one very, very useful tool is the extent rectangle. So right click on the data frame, go to properties, extent indicator is called in mine. In yours it's called extent rectangle. Just select one of your other data frames and click OK. And there it draws on the location of this data frame. One thing I'm just going to do is I'm just going to neaten up the actual alignment and sizes of this particular data frame so it all looks very neat and fits on. That's it, pretty much. So now there's a lot of things that you can do. For example, we need to start getting some extra information on, i.e. what does these particular colours mean on the map. So what I'm going to do is just go Insert, Legend. I want one of these layers. You see it's not showing for me. Just going to go properties of this particular thing. And only display layers that check. It will now display the full legend that I'm interested in. Now luckily, you can automatically format your legend just by clicking Style in the legend area here. This is my favourite legend with its horizontal barrel. Click Apply. We've now got a legend coming down, my favourite one. But as you can see, we've got value, legend, what does that mean? Let's click on it again, go into properties, you see that we've got a title, we can change it to habitat, suitability, apply. I'm going to turn off some of the items in here, so I'm going to click Style, Properties, I can turn off heading, click Apply, okay, apply, and that will now go. So now it's much neater, much more professionally looking legend. Now I'm just going to do a few little arty parts. I'm just going to add a little bird at the bottom. Right click on it, order, send back, properties. I'm going to change the colour to a nice colour that I use to theme my particular map. And then using the text box, we can now start getting some metadata into here. Okay? So, down here you might want to put the AUC values, exactly what the map shows. Okay, you probably put that in there. You might put at the top. A nice title or banner. You will put information in about the predictions, the strength of the predictions, the AUC value. You might put in here what coordinate system the data is in, so that people can see that automatically. So if you spend a bit of time doing it, you can end up with something which looks really professional, as I'm going to show you when I've loaded it in. Bear with me for a second as I try and find the map I drew on Friday night. Not drained everywhere. In here. I don't know where it's getting. Okay, so here is the map I drew during the practical session. And as you can see, I've done it exactly the same way I did in the demonstration that I've just recorded. And you can see that I've got the points, I've got four different species. Down here I've got some information about it, habitat suitability, I've got some nice descriptors about what this actual map is. That's what you're aiming to achieve with producing a professional quality formatted map. Okay? Thank you very much.